Okay, for the next question, we are actually doing this question such that there's a description here on the situation, but by looking at the diagram, you should more or less know what is actually going on. Just take note that actually OP itself is actually X and OQ is actually Y. Now, the very first part of the question is you're supposed to use similar triangles to show that the relationship between Y and X is as shown by this equation. So by looking at the triangle QPO and this particular triangle here, okay, now why this triangle is being chosen is because I actually know that this length here is actually 3/2. Okay, and this particular length here, well, since this length here is actually 2, I know that this length will be x minus 2. So using all this information, by using similar triangles, what we will actually have is y over x, okay, for the big triangle, will be equals to 3/2 over x minus 2. Okay, this one is for the small triangle. So just by tidying up the equation that you form a bit, you will be able to get what the answer requires from you. Okay, so once this is done, now we can actually do A. We actually given that the x is increased at a constant rate of 0.1 meter per second squared. This is actually telling you that we actually know dx dt. And this question is we will be dealing with rate of change. So we have to find the rate of y when x equals to 3 meters. So this is what we want. Okay, this is what we want, this is what we have, which means that the chain rule that we need will be something like this. dy dx times dx dt. So the very first thing is we need to find dy dx, and we can actually find dy dx using the equation that we got earlier on. Okay, so once all this strategy is being done, or being actually derived, I'm ready to actually solve part A. Okay, so first thing first, we know that dx dt is equals to 0.1. We want dy dt, target. Okay, dy dt is the target. This is what we want, this is what we have. Chain rule, this is what we need. So from just now, we know that y equals to 3x over 2x minus 2. So dy dx will be equals to, okay, usually what, to keep our question simple, keep the 3/2 outside. So I will be using quotient rule, x minus 2 square, hold the bottom, differentiate the top. Okay, just to make sure that we understand what we are doing, what I'm saying is y equals to 3/2 multiplied by x over x minus 2. I'm actually differentiating x over x minus 2. So square the bottom, hold the bottom, differentiate the top, minus hold the top, differentiate the bottom. Okay, so this will give you x minus 2 minus x over x minus 2 square. 3/2 minus 2 over x minus 2 square. Okay, do a bit of tidying up. Minus 3 over x minus 2 square. So dy dt is equals to minus 3 over x minus 2 square multiplied by dx dt is 0.1. And do remember that definitely we will have to actually sub something for x. And if you read the question just now very carefully, okay, when x equals to 3 meters. So going back, and you will get the answer as negative 0.3 meters per second. The negative sign is actually very important because it's telling you that the y value is actually decreasing. We are supposed to do part B. Okay, the situation is that now two workers are trying to transfer a frame painting of dimension 5 by 5 meters. Just take note that it's actually just a square, okay, frame. Okay, from point A to point B, which means that the workers will actually have to pass through this corner here. Okay, this corner here. Now by using differentiation, show that the minimum value of PQ equals PQ square, okay, equals to 24.3. Okay, let's erase all this from the previous part A. So what we actually need to do is we need to show that the minimum value of PQ square, which is this one, okay, minimum value of PQ square, which I can call it L, okay, okay, PQ square. Okay, maybe later I will actually set it to be L. Reason being that later we all know that to actually find the minimum value of PQ square, we need to actually do differentiation. But before we can even do that, we actually have to form ourselves an equation to differentiate. So one look, we should know that we should be making use of this right angle triangle. Okay, this right angle triangle. And tell ourselves that PQ square by Pythagoras theorem is x square plus y square. Okay, so we will start from here. Okay, PQ square equals to x square plus y square. And because we want the minimum value of PQ, so technically speaking, we are actually doing something like differentiate PQ square d something. Okay, d something. Now, if you take note of it, you can see that both x and y are changing, which means that both are variables. Just remember that in A-levels exams, if you actually faced with questions whereby you have to find the minimum maximum, and there are actually two variables, there is always a condition for you to actually change one into the other. And actually just now we actually show that y is actually equals to 3x over 2 bracket x minus 2. So we can actually do this. And hence I actually change it to one variable. Okay, so once it's done, okay, in order to later simplify our working, I will call PQ square L. Okay, so my job is to actually show that the minimum value of L is 24.3 as according to the question. So we know that we have to do the L dx, but before we do that, let's tidy up the, okay, actually okay, what we actually do now is we can actually take out the constant to make the differentiation later a bit easier. So now really we can do the L dx 2x plus, okay, 9 over 4, so power drop down, 18 over 4. Okay, then differentiate by chain rule. Okay, which means that I actually will have 2x plus 18. Okay, 18 over 4 is basically just 9 over 2. Okay, x over x minus 2 multiply by x minus 2 minus x over x minus 2 whole thing square. This will means that 2x, so this will means that dl dx is 2x plus 9 over 2. Okay, this will be minus 2, so let's combine both things together. I will actually get this. And okay, for L to be minimum, okay, the question actually say minimum. Okay, what we actually need to do is that I have to set the L dx equals to 0. Okay, so 2x plus 9 over 2 okay. Hence, this will be equal to 0. Now, to actually solve this, what I need to do is I have to make this whole thing one big fraction. Okay. This will imply that 2x x minus 2 cubed minus 9x equals to 0 is the equation I want to solve. Okay, what's this? So this will imply that x is equal to 0. This is not possible because I actually want to actually have some length PQ. If you actually have x equals to 0, that's not possible. Which means that I'm solving for this. Which means that I know that my x value is actually 9 over 2 to the power 1/3 plus 2. Okay, so once this is done, let me check what is my PQ square again. PQ square is this form here. Okay, let me do this. Okay. Okay, so this is PQ square. Okay, this is PQ square. Okay, but before we do that, we have to actually do a check that for this value of x, okay, for this value of x, okay, which is 9 over 2 1/3 plus 2, a bit less than 9 over 2 cube root plus 2, a bit more than 9 over 2 1/3 plus 2. Okay, so your dl dx will be 0, negative, positive. Okay, and once so actually you have to say therefore for x equals to 9 over 2 1/3 plus 2, L is minimum. So by putting this in, 2 square plus 9 over 4, 9 over 2 1/3 plus 2, 9 over 2 1/3 square, you will actually get the answer as 24.3. For the very last part of the questions, after we actually determine that the minimum value of the PQ square equals to 24.3, which means that the minimum value of PQ is square root 24.3, which is actually 4 point something value. Okay, we can actually do a quick calculations. Okay, so square root 24.3 is actually 4.93. Okay, let's write it down first. Okay, 4.93. Now, so the workers actually have to transport this frame painting of dimension 5 meter by 5 meter, okay, to actually pass by this corridor here. Okay, pass by this corridor here. But the thing is this, the thing is that when they're actually passing by the corridor, they will actually have to actually let their frame painting, by the way, the frame painting is actually square, so no matter how they actually hold it, the length will always be 5 meters. So going through this corner, there will be a point whereby they actually can have only a space, because the minimum value of PQ is 4.93. They can only have a space of 4.93 to clear the dimension of 5 meters. Okay, so hence when they actually reach that minimum value, there's no way for the frame painting to actually clear the corridor, and therefore they will not be successful in clearing the corridor itself. So the answer is they will not be successful since the dimension of 5 meters will not be able to clear the minimum length of PQ, which is 4.93 meters, that they will encounter when turning around the corner.